Welcome to ITSW 1307, Introduction to Databases. We will begin with Chapter 1, answering the question, what is relational? We will begin with a broad overview of the different types of databases. As this course focuses on relational databases, we will cover a brief history of the relational model, and we will end with the anatomy or the structure of a relational database. What are the different types of databases? There are quite a few. We will take a broad look, beginning with what is a database? It's an organized collection of structured information, structured being a key word here, because now in the age of big data, we also include unstructured data. But this course focuses on relational databases, and relational databases store structured data. The data is typically stored electronically in a computer system. It is usually controlled by what we call a DBMS, a database management system. What is a database management system? It serves as the interface between the database and its end users, which would be us, or programs. The DBMS allows users to retrieve data, to update data, and to manage the data. People who manage the data are called database administrators. The DBMS also facilitates oversight and control of the databases. This also falls under the responsibility of a database administrator, whereas we are more like the end users extracting the data to use for analysis. A DBA can perform tuning and performance monitoring of the database, and he can also, or she can back up the data, and if the data is lost, recover the data from a backup. Some popular examples of popular database software or DBMSs include MySQL, Microsoft Access. You may have learned that in your BCIS 1305 class, Intro to Business Applications. Another example of a popular database is Microsoft SQL Server, Oracle Database, FileMaker Pro, and DBase. Beginning with a relational database, let's look at a little bit of the history here. Relational databases became dominant in the early 1980s. The structure consisted of sets of tables defined by columns and rows. Next, we have object-oriented databases, and they are represented in the form of objects and are based on object-oriented programming. Notice the structural difference between a relational data model and an object-oriented data model. Distributed databases. Well, they would be the opposite of centralized. Distributed databases consist of two or more files located in different sites. They are stored on multiple computers at these different sites, and they're located in the same physical location or scattered across different networks. Therefore, for example, you could have a distributed database system in Houston, or you could have a distributed database that spans Houston and other states, or we could have databases that are distributed internationally. What is a data warehouse? It is a central repository for data. It is a type of database specifically designed for fast query and analysis. We will touch on data warehouses in this course just for a context of all databases, but again, we will focus on relational databases, and I want you to understand that a data warehouse is not, in general, a 100% relational database. It's a step above because it uses aggregated data, whereas in a relational database, we have raw data. What is aggregated data? It's when we take lots of data and perform an aggregate on it, such as sum, the function sum, such as the function count, and we just save those results of the functions in the warehouse. Notice the difference in the design of the warehouse to the distributed database. NoSQL database is a non-relational database. I emphasize non-relational. Unstructured data is stored in a NoSQL database. It grew popular with web applications, with social media, with big data. And this is just an example of the popular NoSQL databases. Let's take a brief history of the relational model. The relational model was formally defined in June of 1970 when Dr. Edgar F. Codd published his white paper, A Relational Model of Data for Large Shared Databases. Prior to his publication, prior to relational models, data was saved in a hierarchical fashion. The relational model is based on set theory and first-order predicate logic. We will not delve into the mathematics behind the relational model, but we will be working extensively with the relational model by using standard SQL statements. In the early 1970s, with the definition of the relational model defined and accepted in the industry, we see the development of relational database management systems, beginning with IBM's System R and the University of California's Ingres. In the 1980s, we saw a move to commercial mainframe databases by Oracle and Microsoft. In the late 1980s and early 1990s, we moved from commercial mainframe databases to commercial client-server databases. In 1992, William Inman, known as the father of data warehousing, published his book titled Building the Data Warehouse. That led us to data warehousing on client-server structures in the early 1990s. As we moved through the 90s to the early 2000s, the databases also moved to the internet and to cloud storage. Now let's discuss the anatomy of a relational database, which is essentially the structure of the database. A database consists of tables that contain the data. A table is a representation of a person, place, or thing, and can even be a representation of an event. A table must contain at least one field known as the primary key so that the rows or records in the table can be uniquely identified. The basic structure of a relational database consists of tables that are related to each other. A table consists of rows, which are also called tuples or records, and a table consists of columns, which are sometimes referred to as attributes or fields. In general, when we are discussing an entity and the logical description of that entity, we use the term attributes. When we are discussing the design of that entity on a form or a website, we use the term fields. Keys are used to uniquely identify a row in a table. In the agents table, we see agent ID is the key. Agent ID will allow us to select each row in a table. For instance, agent ID 3 will only retrieve the Carol record. Agent ID 1 will only retrieve the William record. In the entertainers table, our primary key is entertainment ID. 1001 will only retrieve entertainment name Carol Peacock. Now what is this right here? Agent ID. Agent ID 1 links us back to the agents table to William. Agent ID is considered a foreign key in the entertainers table because it is a primary key in the agents table, but as a foreign key, it connects entertainers to agents. A primary key is used to ensure table level integrity. By integrity, we mean the consistent and complete and accurate data stored within the table. Foreign keys help ensure referential integrity. In this example, agent ID is the foreign key. In the entertainers table, it helps to ensure referential integrity to the agents table. What do we mean by that? We mean that this number 1 in the entertainers table links back to number 1 in the agents table, and that the 1 is only used for William Thompson. Now let's take a look at views. Views are considered virtual tables, and they are made of fields from more than one table. Yes, you can have a view on one table where you select just the columns that you want in the view. So in that case, a view is a subset of one table. Now, any changes made through a view is actually happening to the underlying source table. Views make it very easy to write SQL statements when we are dealing with very large tables. As this is a relational model, let's discuss relationships. There are 3 types: one-on-one, one-to-many, and many-to-many. Here we see an example of one-to-one. Each agent has one salary. In a one-to-many, in this example, entertainers are related to engagements. One entertainer can have multiple engagements. Engagement 10 and engagement 5 are related to entertainer 1003, which is JV and the Deep 6. So we see here a relationship of one entertainer to many engagements. Each entertainer in this table can have multiple rows in this table. Here we have a many-to-many, which is usually a relationship we have to resolve down to a one-to-many. Many customers can have many entertainers. Many entertainers can have many customers. That makes it difficult to extract a unique row in a timely manner. Therefore, here we resolve the many-to-many relationship by creating this middle table called a linking table. Now we have the relationship of a customer with many engagements. That's a one-to-many. And from the bottom here, we have an entertainer with multiple engagements. This is a one-to-many. So we have resolved the many-to-many between customers and entertainers by creating a linked table, and the linked table allows us to have a one-to-many between customers and engagements, and a one-to-many between entertainers and engagements. For week 1, lesson 1, we just covered the different types of databases, a brief history of the relational model, and the anatomy or structure of a relational database, which is based on relationships between tables, and the structure of a table consists of columns and rows, very similar to what you see in Excel. This week's assignment for Chapter 1 is just a quiz. You do not have a lab assignment for Chapter 1. Keep in mind that your Chapter 1 quiz is due by 11:59 p.m. this Sunday night.